Hello everyone, welcome back. Today we will continue our second lecture. In these lectures, we will introduce you chapter 2. This chapter is the introduction to relational data model. In these chapters, I will introduce some conceptual foundations of relational data models. First, we will try to learn about the structures of relational database, including the components of relations and some terminologies associated with relational data model. And we will learn about how to express logical structures of database with schemas. In addition, we will try to learn about the concepts of keys. In relational data models, there are different types of keys. So today we will try to explore the concepts of keys. Particularly, we will spend a lot of time on introducing primary keys and foreign key. After explaining the concepts of primary key and foreign key, we will continue to introduce two integrity constraints, which can help data consistencies while transactions is processed. We will try to understand the delete or update rules for foreign keys reference in order to improve data consistency. Now let's start today's lecture. It's an example of an instructor relation. In relational data models, a relations usually refer to a table. For each relations, we have to assign the relation names for it. The stars we store is related to instructors, so we call it instructors relation. In these relations, there are 4 columns, which also can be called attributes in relational models. The 4 attributes include ID, name, department names, and the salary, which are exact the properties we abstracted from general instructor. According to these 4 attributes, each instructor can be stored here, and each row represents an instructor. And in relational data models, the rows has formal terminology as tuples. As to the set of allowed value for each attribute can be called the domains of attributes. That is, the value appears in each attribute have to satisfy the requirements of domain. In addition, attributes values are required to be atomic. That is, it cannot be the set. And the null is the spatial values for attributes. The null is usually indicated that the value is unknown, and these kinds of values sometimes can cause complications in the definitions of some operations. So, according to these explanations of various terminologies in relational data models, I think Everyone should possess the abilities to understand the components of a relation and its contents. In order to understand the size of a relation, we can use two terminologies, cardinality and degrees, to measure the size of a relation. Cardinalities means the numbers of tuples in the relations. For example, in the instructor's relations, the cardinalities is 12 because there are 12 tuples in these relations. As to degrees means the number of attributes in the relations. In these relations, there are 4 attributes, so the degrees is 4. If you can understand the meanings of cardinality and the degrees, now I think everyone can try to answer this question. What is cardinality and the degrees of the department tables? I will give you 3 minutes to finish these questions. So later, I will discuss the answer of these questions. Okay, now let's discuss the answer. In these department tables, there are 7 tuples, so the cardinality is 7. And because there are 3 attributes, the degrees is 3. When we want to understand the structures of a relations, there is another important part we have to notice. That is, the tuples in the relations may be stored in arbitrary orders. So in these situations, orders of tuple is irrelevant. That is, we don't have to concern this data is stored in ascending orders or descending orders. We can look at these instructor relations. It can be found that all the instructors are stored and without any orders. In order to improve the efficiency of communication, database schema is usually used to represent the logical structure of the database. And a database instance means a snapshot of the data in the database at a given instance in time. And now, we also take the look at the example of instructor relations. Here, we can represent the structures of relation instructors with schema like this. First, we have to indicate the relation names, such as instructors, and followed by a pair of brackets which contains 4 attributes inside. With schemas, we can easily express the structures of a table. As to instance, it mainly refers to each tuples in the tables because it records all the attributes values associated with the instructors, so it can be regarded as an instructor instance. So overall, schemas emphasize the logical expressions of relations, whereas instances emphasize the real data associated with the real object. After exploring the structures of a table and database schema, now I would like to introduce you some concepts of key. In relational data models, there are different types of keys. First is superkey. Superkey is the set of attributes which are sufficient to identify a unique tuple of the table. In other words, any combinations of attributes which can help find out a unique tuples in this table. The combination can be called superkey. And now we take the instructor tables as example. In these tables, if we want to find out a unique tuple, we can use ID or combinations of ID and name to find out the unique tuples. The reason why IDs can be used as superkey to help identify the unique tuples is because ID value is not duplicate. With these unique values, we can identify a specific tuples in these tables. As to the combinations of ID and name, this combination is still unique for identifying the unique tuples. Accordingly, in addition to ID and the combinations of ID and name, there are more and more combinations of attributes which are not duplicates, so that can help identify a unique tuples so that they can be regarded as superkeys. And then I will introduce you candidate key. Candidate key is the keys ready to be primary key in the future. So the purpose of candidate keys is to identify the unique tuples. In these situations, we can choose candidate keys from superkeys. In addition, candidate key has to be minimal. In other words, the minimal combinations of attributes for identifying a unique tuples can be regarded as candidate keys. In instructor tables, IDs is the simplest combinations of values for identifying the unique tuples. So ID is a candidate key for instructors. Primary key. Primary key is the keys can identify a unique tuple of the tables. In fact, The candidate keys may be many, so we have to choose one of the candidate keys as the primary key to help identify a specific tuple. After the candidate key is determined, these primary keys can first used in data query by user in the future so that it can speed up data queries. And these primary keys usually can be indicated with underlines. For examples, if ID is the primary key of instructor tables, it can be underlined along with the attribute ID. So, if user submits a query's comments, this primary key is first considered to be used to identify the unique tuples and to avoid some ambiguity phenomenon. And now let's consider other tables and their primary keys. Department tables. In these tables, there are three attributes: department names and its building's budget. Here's department name is the primary key. Because the primary consists of single columns, we can use the values of department name to find out a specific tuple in these tables. If we use biologists, we can easily find out the other column associated with these tuples. And now let's consider the teacher's relations. These relations contains 5 attributes: IDs, course ID, session ID, semester, and the years. Let's explain for these tuples. It means instructors 10101 teach course CS 101 in the first sessions of semester 4 in 2017. In these tables, we can find any single attribute is duplicate. Here is duplicate. Here's. So any single column is not qualified to be primary keys due to duplications. We have to consider more attributes to be a combination and make sure it's unique for identifying the specific tuple. If we combine ID and the course IDs, and we can find these two tuples still duplicate. So we have to enter session ID into these combinations. The combinations of these two tuples is not duplicate, but considers the same instructors. It's possible to teach the same course in the same sessions. So we have to add other attributes such as semesters and years to make sure it will be duplicates in the futures. So here's the primary key consists of 5 attributes. In other words, all the attributes of these tables combines into the primary keys. So this primary key is also regarded as a composite primary keys and consists all the attributes of these tables. According to the explanation related to primary keys, each table in the university database can be expressed with schema. Here, we can easily understand all the tables and their components. For example, classroom has 3 attributes: buildings, room numbers, and capacity. And the combinations of buildings and the room numbers is the composite primary key. So with these primary keys, we can easily identify the specific classroom in this table. Departments has department names, buildings, and budget. Here's department name is the primary key. Course describes all the data associated with course. Here's it records course ID, titles, department names, and the credits. Course ID is primary key. And the instructors includes ID, name, department names, and salaries. Instructor ID is the primary key. Sessions consist of these attributes, and the primary keys composed of course ID, session ID, semester, and the year. Teachers records ID, course ID, section ID, semesters, and years, and all the attributes are regarded a primary key. As to the students' tables, it records all the data associated with the properties from students. There are ID, names, department names, and the total credits. And the ID is primary key. Text consists of these attributes: ID, course ID, session ID, semester, years, and grade. It describes the students takes some scores in some times and obtains the grade. So here's the combinations of ID, course ID, session ID, semester, and the years is the primary key. Advisors includes SID and IDs, and these 2 attributes forms the composite primary keys. And the time slot consists of time slot IDs, day, start time, end time, and these attributes are primary key. Finally, pre-requirements consist of course ID and request IDs, and both of them are primary keys. So with schemas, we can easily express the components or the tables in the database. If you can understand the concepts of primary keys, here we have an exercise and students can practice with 15 minutes. This exercise is please find primary keys for each table of database company and underline the corresponding attributes. And the company database includes 4 tables. They are employees, departments, projects, and project assignment. Now, let me explain these tables and their components. First, employees. Employees tables records all the data associated with employees. For example, the employee number, employee names, and the department. It records these employees and its names and which department she or he works in. So these tuples reveal the fact employee 14, her name is Janice and works in department 2. As to department records the attributes related to department, for example, department numbers and the locations. Department number 1 is located in Taipei City, and the project illustrates the attributes associated with projects such as project numbers and the project name. For examples, P1's projects mainly concerns the development of product A, and the project assignments mainly records employees' numbers and the project numbers. These tuples means employee 15 involves project P2. So if you can understand the meanings of each table, you can try to find out primary keys for each table. And 15 minutes later, we will discuss the answer. In order to help you to answer these questions, there are some tips for you. For each table, if you want to find out primary keys, you can try to search for combinations of attributes, including single attributes and multiple attributes. First, let's begin with single attributes. First is employee numbers. The employee numbers is the values of these attributes is unique. So employee numbers could be as primary keys. We can continue to search for employee name. And then we can find that the employee names is unique so far, but it's hard to confirm the same names won't enter these tables in the future. So if we have better choice, we won't choose employee name as primary key. And the department is clear to see there a duplicate. So it's not suitable for being primary key. After comparing the singles attributes, we can find employee numbers is suitable for being primary keys because it's unique. That is, the unique values can identify a specific tuple in the future. And if single attribute is not unique, we can try to search for a combinations of two attributes. If two attributes combination is not unique, we can try the combinations of three attributes until the combinations using all attributes. In the worst case, all the attributes can be used to be primary keys. So in employee tables, the primary key is employee number, and the rest of the tables in this database, students can use this tip to find out primary keys for each table. If everyone finished this exercise, we will discuss the answer now. According to the tips I just mentioned, employees' numbers is the primary keys of employees' tables. Due to it does not duplicate. As to the rest tables of this database, we will apply the same principles to identify their primary key. The department's tables contains two attributes, department numbers and locations. First, we will examine department number, and we can find it is unique so that it is qualified to be primary key. As to locations, although it looks be unique so far, it's hard to measure. The value is always unique forever. Imagine that situations in the future, there's a different departments located at the same cities. For example, Taipei City. So locations may be duplicates in the future. So it is hard to measure the duplications of location. So compare locations, department number is more suitable for being primary keys of departments. And the project has two attributes, project numbers and project name. The values of project numbers is unique, so that it is candidates for being primary keys here. As to project names, it is still hard to measure unique value forever. So compared to project name, we will choose project numbers as primary key due to its unique. And the project assignment, if we examine each attribute, we can find employee numbers is duplicate, and the project numbers, there are also the duplicate here. So if each attribute is not unique to be primary keys, we can try to combine two attributes, and we can find the combinations according to the properties of relations data models. There's no duplicate tuples in a table, so if we use all the attributes as and combine them to be primary keys, we can measure these tuples must be identical in this table. So we can use employees numbers and the project numbers as primary keys. That is, project assignments has composite primary key. After exploring this exercise, I think everyone can understand more about the concepts of primary key, followed by primary key. Now, I would like to introduce you the concepts of foreign key. Compared to primary keys, which concerns more about the internal contents of a table. Foreign keys concerns more about the relationships between different tables. So we can define the foreign key as the non-key values in one relation, and these non-key values is actually the candidate key of another relation. One is the referencing relation, and the other one is the reference relation. Here, I will use the instructor tables and department table as example to explain what is foreign key. As to the session relations, these tables consist of the following columns: course ID, session ID, semesters, years, buildings, roll number, and the time slot IDs. Here, it can represent bills 101. This course is taught in session 1 and is taught in semesters of 2017. The building is Painters and room numbers is 514 B time slot ID. So if we want to identify the unique tuples in these tables, we have to use the combinations of the four columns. If we use single columns, such as course IDs, there are some duplicate phenomena. So these duplicate values cannot help us to find out the specific tuples. In these situations, we have to text the combinations of more attributes, and with this unique combination to find out a unique tuples. So here, the primary keys consist of course ID, session ID, semesters, and years. Because the primary keys contains more than one columns, so here we can call this kind of primary key composite primary key. With the combinations of the values, we can easily find out the specific tuples here. And now let's take a look at these two tables. One is instructor tables and the other table is department. The instructor tables records the attributes associated with instructors, including ID, name, department names, and salary. As to department tables, it records the data related to the department, including department names, buildings, and the budget. We can find department name is the common attributes of these two tables, and department name is the non-key attributes of instructor table. The same attributes exact the primary key of department tables. So here we can regard the department name as the foreign key of instructor table, because we can get more information through this referencing relationship to another table. And now we'll use the pupils to explain how foreign key works. For examples, instructor with ID 12121. His name is Wu. He works in finance department and with 90,000 salary. If we just examine this table, what information we can get from this table just limited to the department name, finance. And we have no ideas about other information related to finance department. However, with the add of foreign key reference into the other tables, we can find out more information about finance department. For example, this department is located Panther buildings and its budget. So with foreign keys, we can get more information through this referencing relationship. Here, department name of instructor table mainly deal with referencing to another's tables. So it is called referencing relation. And the department name of the department tables is reference. So that department table is called reference table. Based on the concept of foreign key I just mentioned, now let's try to define foreign key for each table of university database. When we define foreign key for each table, we have to consider the non-key attribute first. For examples, in classroom tables, it has composite primary key which consists of buildings and room numbers. So it is clear that capacity is a non-key attribute. Here it has to be noticed that any part of the composite primary key need to be treated as non-key attributes. Accordingly, buildings and room numbers should be treated as non-key attributes because they just one part of the primary key. We have to check whether these three attributes are the primary key of other tables. And we can find none of them are primary key of other tables, so that we can conclude classroom has no foreign key. As to department table, the primary key is department names, and the non-key is buildings and the budget. So we have to check whether buildings or object is the primary key of other tables. And we can find that both of them are not primary key of other tables, so that we can conclude that departments has no foreign key. As to the course table, the course ID is primary key, and title, department name, and the credits are non-key attributes. Department name is the primary key of department, so we can define department name is the foreign key of course table, and these foreign keys will reference the primary key of department table. As to instructor tables, we have explained that it has a foreign keys department name, which references the primary key of department table. And the sections table. In addition to non-key attributes, we have to consider each attribute of this composite primary key as non-key attribute. In other words, we have to examine each attribute of this table to make sure whether one of them is the primary key of other table. After examining, and we can find none of them is the primary key of other table. So that section table has no foreign key. As to teachers table, which mainly describes the situations that instructor teach which course, and the primary keys consist of all attributes. So each attribute of the primary key must be treated as non-key attributes. Thus, we have to make sure each attribute is the primary key of other tables. We can find ID is the primary key of instructor, so it is the foreign keys, which references the primary key of instructor. Of course, the course ID is the primary key of course table, so it's another foreign keys for teachers table. And the students tables, we can examine the non-key attributes and find out department name is the primary key of the department. So here is also the foreign keys, and text tables mainly describe the situations that students study which course. So each attribute of the primary keys need to be checked. Here we can find ID is the student's primary key. So ID is the foreign keys. In addition, course ID is also the primary key of course table. Accordingly, text tables has two foreign keys. As to advisor tables, the non-key attribute is ID, and ID is the primary key of instructor ID. So here it is also the foreign key. Referencing instructor table. As time slot, we can find there's no foreign key, and the pre-requirements, the course ID and the prerequisite ID is both of these two IDs are referencing the primary key of course. So both of them are foreign key and are referencing the course table simultaneously. Because university database consists of 11 tables, we can imagine that the referencing relationships among them should be a little bit complicated. Anyways, through this referencing relationship, we can obtain more extra information from other tables. And this concept brought by foreign key is very important. If you can understand the concepts of foreign key, it's practice time again. Now, I would like to invite you to try to define foreign key for each table of company database. It's suggested that everyone can utilize the answers of previous exercise. In previous exercise, we have indicated primary key for each table, so everyone can further define foreign key based on the previous result. 20 minutes later, we will discuss the answer. So go ahead, everyone. If everyone completes this exercise, we are going to discuss the answer. First, we will examine the employees table. The two non-key attributes only department is the primary keys of other table. So department is the foreign key, which reference the primary keys of department table. And the departments has a non-key attributes location, which is not the primary key of any tables, so that department has no foreign key. The same situation happens on project table. The non-key attributes project name is also not the primary key of other table. So project table has no foreign key either. Finally, project assignments has a composite primary keys according to what I just mentioned. If we encounter the composite primary keys, we have to treat each attribute of the primary key as non-key attributes. In these situations, we have to make sure whether the non-key attribute is the primary key of other tables. And we find employee numbers is the primary key of employees. And the project number is the primary key of projects respectively. So project assignments table has two foreign keys. One is employees number and the other one is project numbers. And here I would like to use the real data in the tables to explain how foreign keys can help us to obtain more extra information. First, let's look at these tuples. Employee number 14. She is Jenny and works in department number 2. So far, the information we received just limited to these tables. In other words, we have no ideas about any extra information about department number 2. And with the reference of foreign keys, we can find out the corresponding department number 2 and know about the fact that department is located at Tainan City. At the same time, let's consider project assignment. It describes the fact employees involves projects. So here we received the information about employee number 15 involves project number P2. And the information just limited to number. However, we can get more information through the reference of the foreign keys and know more about these employees and know about his name and his department. Simultaneously, we also can use the foreign keys to help us to obtain more information about these projects P2 and then retrieve the information such as project name product B. After practicing this exercise, I think everyone can understand more about the concepts of foreign keys and its utilities on database operation. After introducing the concepts of primary key and the foreign key, now we will learn about integrity constraints. In relational model, integrity constraints are designed to ensure the data consistency. As we know, there are a lot of transactions while database is operating. So we need integrity constraints to guard against accidental damage to the database by ensuring that unauthorized changes to the database do not result in the loss of data consistency. In order to achieve the goals of data consistency, there are two integrity rules are designed in relational model. The first one is entity integrity rule. This rule mainly confirms the internal consistency of a table. That is, entity integrity rules is usually to check whether the data in the tables is complete or not. And now, let's take students' relations as example. to show the importance of entity integrity rule. In students' relation, each tuple means a student's entity. And because the primary key is ID attributes, each student's entities has to possess the ID number. And with these ID numbers, a specific student can be searched. If the primary key of a tuple is null like this tuple cannot be searched by primary key because null indicates the value is unknown. It is impossible to find these tuples by primary key. Since these tuples cannot be searched by primary key, it also means this student's entity does not exist in the table. So if the tuples with null value in their primary keys, we can call it violates entity integrity rule. So by checking the value of primary key, we can confirm the data in these tables satisfy the requirements of entity integrity rules or not. If it does not violate entity integrity rules, we can say that this table achieves internal data consistencies. And now let's take a look at another example. It's text relations. In this table, there is a composite primary key, which is composed of ID, course ID, section ID, semester, and the years. And in these tuples, we can find the ID attributes, which is a part of the primary keys, is null, and the nulls of the primary key will result in violating entity integrity rules here. So not only the single value of primary keys, but also the composite primary keys. We have to consider whether the values exist null and to confirm its integrity. And now, everyone can consider the tables in the company database to check whether these tables satisfy entity integrity rules. And here is the tips for you. The tips is students can check the value of primary key. For example, here's employees number is the primary key of employees table. So what you should do is check whether the value is null or not. For example, here's the values of primary keys is not null, so that we can confirm this table satisfies the integrity rule. And now everyone can try to complete this exercise. We will discuss the answers about 15 minutes later. Okay, now it's the time to discuss the answer. I just demonstrated how to check entity integrity rules on employees table, and we found that the primary key employee number of these tables has value, so that employee tables has not the situation to violate the rule. So now we will examine the rest table of this database. The departments tables, its primary key is department number, and here the primary key is null. So we can find that these tuples violate the entity integrity rule. So here's department table is violates the integrity tables. Okay, now it's the time to discuss the answer. In the beginnings of this exercise, I demonstrated how to apply the entity integrity rules on tables to confirm its data consistency, and we found that primary key employees numbers values are non-null, so that there's no data consistencies in this table. And now we will continue to examine the rest tables of this database. The department tables, its primary key is department number, and we find that the primary key values of this tuple is null, which may result in data inconsistency here, so that it violates the entity integrity rules. And the project tables, the primary key is project numbers. The primary key values of all tuples are non-nulls, so that it satisfies the rule check. Finally, project assignment tables. Its primary key consists of employee numbers and the project number, and here's the part of the primary key is null, which also means this tuple has null primary key, so that it violates the entity rules. In fact, in current database systems, if the tuples contains null primary key values, these tuples will not allowed to be stored into the table. So in this database, there are two tables violates the entity integrity rules. They are departments and the project assignment. And now the other rule, referential integrity rule, is introduced compared to the entity integrity rule, which emphasizes the internal data consistency of a table by primary key. The referential integrity rules concerns more on the foreign key and its reference relationship between different tables. Since foreign key is designed to explain the referencing relationship between different tables. Foreign key value is supposed to match with the key values of reference table. If we consider text relations, the tuple with ID 00128, which means this student with these IDs takes course CS101. So these students should be found in students relation. If we can find students the corresponding student's number, we complete this reference. And we can take a look at another tuples. For example, a student's ID with 1, 2, 3, 4, 5. Reference tables. We also can find there are a corresponding student's number with 1, 2, 3, 4, 5. The match values represents is satisfy the referential integrity rules. However, if there is a tuples with ID 11111 in students' relations, it cannot be found the corresponding students. This reference relationships is invalid. That is, it violates the referential integrity rule. In order to make sure everyone can understand the concepts related to the referential integrity rule, now in this exercise, everyone can consider the tables of database company and try to indicate which table violates referential constraint. According to what I just mentioned, the referential integrity rule mainly concentrates on the foreign key. So the value appears on foreign key should on the primary key of the reference table. In other words, the department number 2 should be has the corresponding number 2 appears on the primary key of departments. This also indicates Jenny's works in number 2 department, and this department can be found in the department table. By these referencing relationships, we can obtain the information about department 2. For example, this department is located in Tainan City. And the second tuples, department number 1, and this department number should be found in the primary keys of department tables. As to number 4, number 4 cannot be found the correspondence on the primary key of department, so it violates the referential integrity rules. In addition, it is worth to notice that null values appears on the foreign keys, which means this employee does not belong to a specific department. So we can conclude that the null values can be allowed to appear, and if the foreign keys has null values, it indicates that we don't need to check referential relationships further. As to the rest three tables, everyone can continue to check whether they satisfy these integrity rules. And 15 minutes later, we will discuss the answer. And now let's examine each table and check whether the foreign key values satisfy the reference consistencies or not. First is the employees tables. I just illustrated that the number 4 cannot be found the corresponding values on the primary keys of department, so it violates the integrity rule. As to the department tables and the project tables have no foreign keys, so here we don't need to check their referential consistencies. In the project assignments, there are two foreign keys, the employees number and the project numbers. So we have to individually check each foreign keys to confirm their referential consistency. Here's first we check the employees number, and then we can find the number 15s, 16s, 17s, and the 20s can be found on the corresponding values on primary key of employees. However, employee number 19s cannot be found in the employee tables. It means employees number 19s involve projects, but these employees cannot be found in employees tables, so it violates the referential integrity rule. And now let's check another foreign keys project number. Here we can find P2, P3, P1s, and P4. This number can be found on the primary key of projects, but P6 cannot reference the corresponding values on the keys of projects. So here, this table violates the referential integrity rules. The answers, the tables of employees and the project assignments is not qualifies the integrity consistency. And now let's explore the last part of this chapter. It's delete and update rules for foreign key reference. In order to maintain foreign keys and its referential consistency, three delete and update rules are provided here. These three policies include restricted, cascaded, and nullified. In restricted rules, the tuples of the reference tables only can be deleted under some conditions. The conditions is the tuples is not referenced by other tables. Because the deletions of some tuples may cause reference values from other tables. In these situations, the deletions will be restricted. We can think about a scenario that if we want to delete the students with ID 00128, if the deletion is successful, it will result in reference values from the tuples with the same student's ID of text table. In order to avoid the reference values here, the deletions of corresponding tuples will be denied. However, if we want to delete 70557, the deletions will be allowed because this tuple is not referenced by any other tuples of text relation. So if we adopted restricted policies, the deletions of some tuples will be restricted and it will successful only there's no reference by other table. As to cascade rules, if the tuples of the reference tables is deleted, the correspondence of other tables need to be deleted simultaneously in order to avoid reference values due to the tuples deletion. Now let's examine students' relations. If we want to delete the students with ID number 00128, at the same time, the corresponding text records with the same student's ID will also be deleted. With the cascade actions, the referential relationships can be confirmed here. And if we want to delete the students with 70557, we don't need to delete any tuples of other tables because this tuple is not referenced by anyone. So here's if we adopt cascade policies, not only the tuples of reference table is deleted, but also the tuples of the referencing table will be deleted too. In nullified rules, if a tuples of a reference tables is deleted, the corresponding tuples need to be updated by replacing the foreign key values with null value. For example, if students with student IDs 00128 is deleted. The foreign key values of these two correspondings need to be updated as null value. So nullify policies not only can avoid the phenomenon of reference values, but also can retain the original data status. However, we have to notice that nullify policy is not suitable for the situation that foreign key is one part of the primary key. Because null values appears in primary key will produce a side effect which violates entity integrity rule. The examples I just explained are related to delete transaction, and the same three rules also can be applied to update transaction. First, if the restricted policy is adopted before the primary key of a student's tuples is planned to be updated, it is needed to check whether this tuple is referenced by other table. If yes, the primary key's values cannot be updated. If not, the update transactions can be processed successfully. Whereas, if we choose cascade policy, if the primary key of a student wants to be updated as 11111, the corresponding tuples of the referencing tables should be updated simultaneously. And if nullify policy is considered when the primary key of the students is updated as 11111, the foreign keys of the corresponding tuples in text relations need to be updated as null. However, in the situations that foreign key is one part of the primary keys, the nullified policies cannot be allowed to be used here, because the null values of the foreign keys will result in the situations that null values appears in primary key. In other words, these situations will produce the violations of entity integrity rule. Accordingly, if nullify policy is adopted, we have to be careful about this kind of situation. After expressing the introduction to this chapter, I think everyone should understand more about the relational model.